Hello everyone, System Shogun here. Today we're diving into Azure Cosmos DB partitioning, one of the most important concepts if you want your app to scale globally and stay cost efficient. Before we get to partitioning, let's quickly talk about Cosmos DB APIs, because Cosmos DB isn't just one database engine. It supports multiple APIs for different workloads. So we have Core or NoSQL API, which is JSON documents with SQL-like queries. We have MongoDB API, which is compatible with MongoDB. We have Cassandra API for wide column data, Gremlin API for graph relationships, Table API for simple key-value data store, and the latest one, Postgres API for relational and vector workloads. In this video, we'll focus on the first one, Core NoSQL API, the most commonly used one. Now, let's understand the structure of a NoSQL database in Cosmos DB. Think of it like this. A database is like a folder. It holds everything related to one application. A container is like a table. It stores your JSON documents. An item is one JSON document inside that container. So, the hierarchy is database, container, item. This structure is key to understanding how partitioning works later on. Before we talk about partitioning, let's cover request units, or RUs. Every operation, read, write, query, or delete, consumes RUs. They represent the CPU, memory, and IOPS that your operation uses. So instead of managing hardware or performance settings, Cosmos gives you one simple metric. You get predictable performance because Cosmos ensures all requests fit within your RU budget. Now that we've covered the basics, let's make things practical. Throughout the rest of this video, we'll use a simple e-commerce example to explain partitioning. Think of a typical online store where users can browse through categories like phones, cars, books, clothes, and laptops, view products under each category, check out reviews for each product. This scenario is perfect for demonstrating how partition keys work and how the right choice can make queries faster and cheaper. So let's jump into how Cosmos DB handles all of that, starting with containers and partitions. Alright, now let's talk about partitioning, the heart of Cosmos DB scalability. In Cosmos DB, each container is divided into logical partitions based on your partition key. Every document you insert includes that key, and Cosmos uses it to decide which partition the item belongs to. Behind the scenes, these logical partitions are distributed across one or more physical partitions, the actual storage units. Depending on your container size, your data might reside on a single physical partition or span multiple ones. This is what gives Cosmos DB limitless horizontal scalability. Let's look at a real example. Our categories container. We'll use ID as the partition key because we only have a few categories. Each category, like phones, cars, books, clothes, and laptops, becomes its own logical partition. Since there aren't many of them, the container easily fits within one physical partition. This setup keeps things simple and efficient for small, relatively static datasets. Next, we have the products container. Users always start by choosing a category first, for example, phones, and then they see the list of phones. That's why we partition this container by category ID. Each logical partition now holds all products belonging to that category. Depending on data size, these partitions might sit on a single physical partition or multiple. This matches our access pattern perfectly, category-based browsing. Finally, we have the reviews container. Each review belongs to one product, so we partition by product ID. That means all reviews for a specific product live inside the same logical partition. When we query for them, Cosmos DB can fetch everything in one go. No cross-partition queries, no fan-out. That keeps queries fast and costs only a few RUs, which is just what we want when we are using Cosmos DB. We want queries to be single partition and to cost just a few RUs. Now that we've covered the theory, let's take a look at this in action. I've built a small demo application that showcases everything we just discussed. Let's jump into the demo. So here is our little demo store where I'll showcase everything that we discussed. On the left, we have a few options. We can create a product or we can go over all the categories. Let's click on the phones category, and here are our phones. So for this demo, I'm using Cosmos DB emulator, and I'll show you in a bit. But now let's click on a single phone, and here it is. Here is all the phone data, as well as all of the reviews. Look at how many reviews we have. Okay, and I'll show you how many RUs are being consumed for each of these operations. I can go under cars, same thing, I have this. Okay, we don't have any reviews for this one. Let's create a product. So we're creating MacBook laptop. We provide some description, a price, and then we'll choose a category, which is laptops. Let's create this product, and here it is. Now, let's take a look at the request units, and here is what we have. Basically, when I was getting all the categories on the left, I consumed 2 RUs. When I was getting products by category, so when I, for example, click here, let's take a look, you see, I consume 5 RUs, which is extremely efficient. When I click on a single phone, which this one is the most important one because we're getting a single phone and like 50 or something reviews with it. Let's see how much RUs will consume. 4 RUs for the reviews, which is extremely efficient. I mean, if you take a look how many reviews we have, it's a lot. But when you design your application and your Cosmos DB data model based on your application flow, based on your exact use case, you can get extremely efficient results like this. That's why it's extremely important first to know how exactly your users will be using the application. In our case, we already know that we'll have a list of categories. When we click on a category, we get all the products, and then you can click on a single product. That's it. That's how our application is designed to work. And once we have that flow, we model our Cosmos DB based on this. And then you get the efficiencies. Otherwise, Cosmos DB can be pretty expensive. If you go online, you see many people arguing, why is Cosmos DB so expensive? Well, it's not if you know how to use it. And this is the core. Start with your application flow, how your application is going to be used, and then based on that information, model your database. So you see, for a single product, we get 1 RU, which is the best that we can get. Let's take a quick look at the solution here. So we have Blazor WebAssembly, we have pages, we have the API with the controllers, nothing fancy. We have the features here. I'll share this code, by the way, with you. So check the description under the video. So let's see, get all categories. So we have this connection string here. This is my emulator. And this is what we do. We get the database, the container, we do some query, and this is the charge on the console that I'm showing. Let's take a look at the reviews. Here is how we get our reviews. So basically we query the reviews based on product ID, which is our partition key, and that's why this is so efficient. You should always strive to query by partition key. Okay, we get all the reviews and then we print the charge. It's pretty straightforward stuff. Let's see how we get a single product. Same thing. So we first get the category, and then based on category, we read items. So this one is the most efficient query that you can have. It costs 1 RU because this is single point. You provide the product ID and the partition key. And that's why we get 1 RU for this, if you take a look at this right here. Before we wrap up, let's take a look at Azure Cosmos DB emulator that I've used for this demo. So we have a demo DB and we have three containers: categories, products, and reviews. Let's take a look at each one of them. So we have phones category, cars, books, etc. We have products. So each product has some metadata like name, description, category ID, name, and we have reviews. So we see how many reviews we have, a lot, and we can load even more. And yeah, that's pretty much it. I decided to use the emulator, but you can try the real Cosmos DB if you want. It's up to you. And that's it for today's video. If you found this video helpful, hit that like button, subscribe to System Shogun, and don't forget to ring the bell icon so you don't miss any of the upcoming videos.